So today we're going to talk about SN1, SN2, E1, E2, and this topic is kind of confusing for a lot of students because sometimes you look at these reactions, and reactants, and you really don't know which one is going to do. You have these four options. How do I figure out if it's going to be SN1, SN2, E1, or an E2 reaction? And today we're going to dispel all your fears, and we're going to kind of make it plain which one it's more likely going to do. So all the factors that I'll talk about today are to try to figure out what is most likely going to happen. It's not going to say that it'll only do an SN1, SN2, or E1 or E2. Most likely in real world situations, it's gonna do a little bit of each of these. It might do an SN1, SN2, or it might be doing an E1 or E2. The major product might be an SN2 product, and the minor product might be an E2 product. But with these factors that we'll be talking about today, we're going to figure out what it's most likely going to occur. And for the MCAT and all your tests, all your organic chemistry tests, they're not going to ask pretty much what's the percentage of SN2 reactions. They're mostly going to ask which is the major product. And with all the factors, we're going to try to figure out, or we're going to try to help you understand what it most likely will be. And all of this is kind of just um, um, was figured out in the past by a lot of different chemists, and they use these factors to help us understand how it is theoretically. But if you look at real world situations, it's most likely going to be a mixture of these reactions. So let's get into it a little bit. Uh, let's have a small introduction about which one is which. So here I have these boxes, SN1, SN2, E1, E2, and I have hyperconjugation underlined over here because that's an important part of uh, why it could be an SN1, SN2, E1, or E2. But we'll talk about that a little bit more, so keep that in mind. So an SN1 reaction, SN stands for substitution nucleophilic, and that kind of just means that the leaving group will be substituted by another group. And it's nucleophilic because what's replacing the leaving group is going to be nucleophilic. It's going to love a nucleus. It's going to love something that's positively charged. So it's attracted to positive charges. Um, so let's say we have methyl chloride over here. That's kind of going to be our model for the rest of what we're going to talk about. So for an SN1 reaction, what's going to happen first is the chloride will leave on its own. It will leave independently. And so we're going to have something like this. This carbocation plus a chlorine group. Now, I'm only writing this product over here, drawing this product for educational purposes, but just know that this methyl carbocation, meaning this carbon with a positive charge, is very unlikely to occur in real life. And that's kind of what we're going to talk about later, why it's not going to be most likely than not, very likely than not, it will never be an S1 reaction because the products will be very unstable. So going from there, what actually happens is, let's say we have a hydroxide, and this will be the nucleophile. So this hydroxide will be our nucleophilic model for the rest of the class. This will attack this carbocation, uh, This carbocation, we call it the electrophile. So electrophile, that's another buzzword that we're going to use, electrophile, because it loves something that's negatively charged. It wants something that's negatively charged, and this is a nucleophile because it wants something that's positively charged. So nucleophile. And our final products will be this over here, this methanol. And then we still have this chlorine or this chloride ion just floating around. So this is pretty much why it's called an SN reaction, substitution nucleophilic, because the leaving group, the chlorine, is going to be substituted by the hydroxide over here, with the alcohol group. And it's nucleophilic because the nucleophile will attack the electrophile. So let's talk a little bit about SN2. So what's the difference between SN1 and SN2? So in SN1, the chlorine leaves on its own. The reactant, or the main reactant, is pretty much just the methylchlorine. But in an SN2 reaction, the nucleophile actually helps that chlorine to leave. So there's going to be two reactants. It's going to be the hydroxide ion as well as the methylchlorine. So in the SN2, all of this happens in one step. In the SN1 reaction, there are actually two steps, the chlorine leaving on its own, and then the nucleophile attacking the electrophile. But in SN2, it all happens in one step. The hydroxide attacks that electrophilic center, and the chlorine leaves because that carbon can't have more than 4 bonds. And so what happens is you get the same product pretty much. That alcohol over here and then the chlorine. So between these two, the SN1 and SN2, we have the same product, but more likely than not, very likely actually, this SN2 reaction will be the one occurring because the intermediate product, this carbocation, will be very unstable. It most likely will never occur because this carbon can't really hold that positive charge all on its own. There will be carbocations that are somewhat stable, and we'll talk about that a little later on. But this single carbon by itself, with three hydrogens, would be very unstable with with a positive charge. So that's SN1 and SN2. To talk about E1 and E2, it's pretty much the same thing in that E1 uh, in E1 reactions, the leaving group leaves on its own, and in E2 reactions, you have a base or nucleophile, but here we call it a base. For E1 and E2 reactions, we call it a base, attacking that electrophilic center. So now we're going to look at E1 and E2 reactions. So E1, E2, the E stands for elimination. So it's called elimination, um, because it's as if the leaving group just leaves and is eliminated, and it's not going to be replaced just like it's going to be replaced in the nucleophilic reactions. So in substitution nucleophilic reactions, the leaving group will be replaced, will be substituted, but in elimination reactions, it will actually just be eliminated. It won't, the final product won't have a leaving group. So in elimination reactions, let's look at E1. Let's say we have something like this. This ethyl chloride. So similar to similarly, E1 reactions will cause the leaving group to leave on its own independently. Um, that's similar to SN1 reactions. So we will have an intermediate product where this carbon has a positive charge. Carbon over here will have a positive charge because it's missing one bond. And then, let's say you have hydroxide again, will come and take a hydrogen ion. That hydrogen ion will leave its electrons to form a double bond between those two carbons, and now you have an ethylene. So the difference between substitution nucleophilic reactions and elimination reactions is that there's no leaving group at the end. There's no um, group left there. In E2 reactions, it's pretty much the same thing, except the leaving group doesn't leave on its own independently. Similar to SN2, the nucleophile, or in this case we call it a base, because it's trying to get a hydrogen ion, and bases love hydrogen ions. So in this case, we call it a base. In SN1, SN2, we call it a nucleophile because it's attacking. But in E1 and E2 reactions, we call it a base. So this base, this hydroxide ion, will actually try to get this hydrogen ion at the get-go, and then that bond between the hydrogen carbon move over here, and then causing this chlorine to leave. So in the end, it all happens in one step, and we get the same product. That should be a hydrogen. So yeah, that's pretty much an introduction to SN1, SN2, E1, and E2 reactions. In the next video, we're going to talk about which one it's most likely to be. And we're going to talk about hyperconjugation and other factors, such as if it's a primary, secondary, or tertiary carbon. All right.